Welcome to the CircuitPython show. I'm your host, Paul Cutler. This episode I'm joined by Pierre Constantineau. Pierre owns BlueMicro, which creates and sells custom mechanical keyboards, Macropads, and more. Pierre, welcome to the show.
Hi, Paul. Thanks for having me.
Glad to have you. Let's start at the beginning. When did you first get into computers or coding?
Well, that was actually quite a while ago. My dad mostly bought me like a ColecoVision Atom. So that was like early 80s, and then that was a very short-lived computer, but it was the computer that I started like just basic programming, and then after that I kind of like abandoned it and just got a PC and just started using it and went to like high school, university, but I was always in the Radio Shack catalogs and like kind of like almost like lusting over like resistors and so on. But then when I got into college, I actually first got into a course of electronics, and it was probably the first maker space, and that was like in early 90s. It was kind of like the maker space of a time where you can like learn about just basic electronics and digital chips, and then during that same year also did like a Turbo Pascal course. So when I entered engineering school, I thought I wanted to be a chemical engineer. Then I switched to, oh no, I want to be an electrical engineer. Then after one course in materials engineering, I went into metallurgy. But I really kept electronics and like ham radio at the time really in computers as a hobby. So, and today what I do at work is really like the marriage of my engineering degrees and metallurgy, but then with computers, because, well, for work, I work with software engineers. So,
Let's talk keyboards. You have a Tindy shop where you sell a few different kinds of keyboards.
Yeah.
How did you get into that?
Well, it started maybe about 4 or 5 years ago when I first started with it, I wanted to know about keyboards and mechanical keyboards. And I first started with like just a plain 60% keyboard, probably from AliExpress, then moved on into building a split keyboard. And at the time it was like a leg split. So essentially a smaller keyboard that's literally split. It can be a little bit more ergonomic. And if I kind of go in it, it runs on two different controllers. So if you can look inside right here, they're Pro Micros. So Pro Micros really they're probably still the one of the most common chip for making keyboards. They're getting harder to get because of a chip shortage these days. But and that's how I got into keyboards. But then a little bit later, there was a fellow on Reddit on one of the mechanical keyboard Reddit that kind of like said, "Oh, here's my split keyboard that uses two feathers, an RF832, like the original feather," and they made himself a split keyboard all wireless, and like feather like this is actually pretty neat. And I thought, oh wow, well I've got this whole keyboard like that lead split that I talked about, and that uses the Pro Micro, and I thought, I got to make myself something to fit on there, because like a feather wasn't really used for pretty, like I'd say 99%. If you build your own keyboard, it was very likely going to be using a Pro Micro. So I thought, okay, I got to build myself something, and that's where I can like first started the BlueMicro. Blue for Bluetooth and micro for the Pro Micro size. So that's where the name comes from. And I created literally this BlueMicro here, and I'm just going to go back into here, literally to make them fit just as a 1-for-1 replacement. Obviously, they're bigger because the modules are not very small, and then they're smaller than the ESP32, but they're definitely larger than the Pro Micro. And then that's when I first really started, okay, I got to build my own firmware for this, because the existing firmware for the AVR boards, like the Arduino based boards, they don't really fit because this is an ARM processor. And even if you look at some of the common firmwares like QMK, they might have a branch, an area where, oh yeah, we support ARM as well, but it's very specific chip. And if you go outside of that, it's not supported. And then the complicating factor with these is there's a Bluetooth stack on it that's a Nordic firmware. It's a bit like a BIOS for a computer. Well, there's essentially a BIOS that takes care of all the Bluetooth things. And so that gets flashed to the chip, and the interface to it, the software dev kit, the licensing isn't quite compatible with the with QMK and a lot of other libraries. So there's more like legal reasons than technical reasons for people saying, no, I don't want to go there because it's one of those like can of worms that, okay, let's not touch it because it just might be a mess, or if somebody comes back and okay, it's not going to be there. So we had to look at, okay, what do I do? So I first looked into, okay, let's get like just a plain SDK from Nordic and just try to see if I can build something. And it was just impossible. It's like after like hours of just trying to get a blinky light, it's like, okay, that's just too complicated. And just kind of looking back, well, there's that feather. It's like, it's on Arduino. Within minutes, I had it running minutes. I had it running on here. So that made it like, okay, like going from hours of work with no success to minutes with, okay, something that, okay, I've got something flashed on here. I can make a light blink. I can build a whole lot more on this.
There's nothing better than that first feeling of seeing that blinking light, no matter which program language you're using or what board you're using. That sense of accomplishment, it always feels so good.
Yeah. And then after this, so this is really where the BlueMicro firmware really came, because I essentially I got inspired from QMK and I said, okay, I want to build something that's flexible enough for other people who want to build their own keyboard to be able to just say, I want to just drop in that BlueMicro and just go on and have my own keyboard. So I kind of built own firmware and then like added a fair bit of functionality over the years. And I just kind of look back, and it was almost 4 years ago when I first had my first commit to the GitHub on that. I actually forked it from like that first code that Reddit guy on Reddit had, and it was like completely different from what it looks like today. But then after that, obviously the 840 came along, which kind of brought in USB. So nowadays it's like a full keyboard, and it's actually pretty neat. Yeah, but yeah.
So you started with Arduino. What actually goes into making your own keyboard? When I look at some of the kits, there's the firmware piece, and then there's like the overlay software to help program it, and then some of the kits require soldering. So
Yep. So let me just kind of pull out maybe one board that I have here. Yeah. Okay, actually, I got something here. So let's just say this is probably my first keyboard that I've actually built with BlueMicro, and so it's essentially a 60% as well. And for those that like don't quite understand 60%, so you've got, and I'm just taking like my wife's keyboard here. So you've got a standard size, which like 110 key. Well, remove the numpad, then you've got what's called a 10 keyless. But then remove the function key in the navigation, then you get 60%. So it's like close enough, like 60 keys over 110, close enough to 60%. And then, so my first keyboard was literally a 60% that I actually plugged in a BlueMicro underneath. And obviously, you need a battery because it's wireless. So, but this PC board is essentially not even my design. It was there's somebody, I don't even know his name, but it's like 40% Club on the internet. So if you just go 40%.club, you'll have a whole blog of somebody who builds just keyboards one-off and just documents it all. But he actually makes his design open source. And I got myself the keyboard and then soldered in all the diodes, and then you can see here, this is the format of a Pro Micro. But how do you go from like a Pro Micro with that is on here to essentially 61 keys? Because if you look carefully, Pro Micro only has 8 input-output pins. So going from 8 input-output pins, this is where the firmware and the hardware, the design of the keyboard really kind of comes in. So the firmware must know, okay, one, which pins are connected where, and then also in what organization. So if I kind of go with, here's a very simple example. Oh, well, actually, let's just take the example of the Adafruit Macropad. I think a lot of people will recognize this. Well, this is probably the simplest if you just disregard the screen and the rotary encoder. This is probably the simplest because literally what you have is 12 different buttons connected to a controller. So it's a one-for-one, a pin to a key, and well, a key is a button, it's a switch. So it is probably the simplest because you only have like one-to-one, it's 12, and then you've got enough pins. But then how do you go from something like, sorry about that, how do you go from 12 to, well,
60
or 87 or even 100? Well, this is where you need to have a matrix. And in a matrix, what you do is you essentially have rows and columns. And then let me just take an example here. So here's a keyboard with 75 keys, and so you've got columns and rows. So each row will be assigned a pin or an input, and then each column will be assigned another pin or another input. Now, typically the way it works is the matrix, either the rows or the column are going to be an input, and then the other are going to be an output, an input, the other one's going to be an output. So that this way you can scan one row at a time and read the entire set of columns. And then you just say, if I turn on this row, read all columns, and then there's a match. Oh, that's because you have a key here. So what you need to do is to scan over all the rows and all the columns to say, am I on, am I on? And then you have your entire matrix of keys of 100 or 80 or 60, all depending. And that's how what the powerfulness, or that's what powerful microcontrollers do, is really do all the scanning.
And it's constantly scanning and pulling.
It's constantly scanning. And that's the first part that the firmware must do, is to understand what that mapping between how to scan. So am I only scanning just pins or a matrix? And how is that matrix organized? Because obviously, if I have, let's go back to that one here. So if I have 18 pin on the Pro Micro, and then I have 61 keys, okay, well, there's multiple ways you can go and divide those. So 18, I could just say, okay, well, I have 10, I could have 8 rows and 10 columns, and then that gives me 80 keys. But then if you count, you've got, I think, 14. So if you do the math, like 14, that's already 14, and you've got like 4 pin left for the rows, but you've got 5. That doesn't work. So the way that this actually is organized, it only uses 16. So it's a matrix of 8 by 8, and it moves some of the keys around to give you a potential of 64 keys, even leaving you with 2 extra pins to do other things. So if you look, this one I've got a little speaker, so it does beeps.
Oh, neat.
And it's got a MOSFET, so it does underglow lights. So it's got all 18 pins used for something.
Hi, it's Paul. I'll get you back to the show in just a moment. Thanks for listening, and if you like what you're hearing, hit the subscribe button and leave a comment that you subscribed. For other ways to support the show, visit circuitpythonshow.com/support. Now, back to the show. So with the firmware constantly polling and scanning, how does it know when the key is pressed? Or where does it send that key press to?
Okay, so any firmware, whichever keyboard to be even called a keyboard, has to do 3 things. So it must be able to do the scanning of all your keys to say, okay, this is the first key, the second key, and so on. Then it needs to figure out when I press a key, what to send to the computer, and then finally sending it to the computer. So let's just start with the sending it piece. So typically nowadays, we're going to have either a USB port, so it's going to talk through a human interface device protocol through USB, or for those Bluetooth controllers, it's going to talk Bluetooth through a very similar protocol. It's also called HID, and then when you go into the details of it, it's essentially the same key codes and the same methods that are being used. So, but then how do you actually go between, okay, pressing a key to sending, okay, I have an A now, or a B? Well, this is where I'm going to start large here. So if you look for a full-size keyboard, just ignore the numpad that's missing here. Well, if you look at this one, there's like 87 key, and then every key has pretty much one function. So if I press escape, it's just going to send an escape. If I press 1, it's going to send 1. If I press Q, it's going to send Q. Now, let's go and move to the 60%. Now, if I go to the 60%, now if you kind of notice here, then I don't have my function key anymore. So what you typically are going to do is going to say, okay, well, if I press Q, I'm going to send a Q. It's 1 to 1. But then if I press 1, I'm going to send a 1. But if I press 1 and a special function key at the same time, this is when I send my F1 instead. Am I even pressing? I might be not pressing the wrong key here, but so this is where you need to have what's called layers within your keyboard. And if you even look some of the even commercial keyboards, and I've got kind of like an emergency one here that's if I run out of keyboard, then it actually even has one of those FN keys to be able to like make those function keys also send like volume controls and so on. So it's not like functions and like those layer keys are not really like a weird thing. But it's whenever you go from, well, something like this, which is actually quite simple to use. You just like, if you use a lot of F keys, maybe you'll be missing them. But where are my arrow keys? Well, for me, what I do for my arrow keys, I kind of press cap locks and I use these 4 keys here. So I find myself like pressing cap locks even on my laptop, and it's just like, I start shouting. But then it gets complicated whenever you go even smaller. Because then you've got this like 40% keyboard, which you've got about 48 keys or 47 keys because this one is double. But then you're losing your number keys on top. So then this means that whenever you press Q, you send a Q, but if you press Q and this key here, then you send a 1, but if you press Q and this key, you press F1. So again, more layers.
3 layers.
3 layers, that's right. So you're getting even more complicated. So when you go from a firmware that needs to say, okay, I have this press key and I send an A, well, if it's a 1-for-1 for a keyboard, the logic is very, very simple. So you can go in Arduino and if just say, if key is 1, send A. If key is B, send B, and so on. But then when you go more complex, the logic gets more complicated. And then obviously there's been specialized firmware that has been developed to be able to do that. So originally there's been TMK and then QMK, which is now very, very popular in the mechanical keyboard community. And because it's a firmware that's already all prepackaged, that you only say, I have this keyboard, and then inside the firmware there's already, it's already the mapping with the pins and the keys, it's already programmed. And then you have the option of say, okay, well, I have this key map, essentially which keys get sent with which key combinations is programmed, and you can load it up. Then there's, so that QMK has really popularized like mechanical keyboards or custom programmable keyboards. But then they've made it even simpler for a lot of people, because now you can actually have QMK with a special firmware. So instead of having a set key map that essentially you have to go and edit, recompile, flash your keyboard, and then compiling and flashing the keyboard. It's not everyone. So that it's not everyone's business to be able to really understand and set it all up. Even myself recently, like I had to kind of reflash some keyboards, and I was like, this is way too complicated. So they've made it a whole lot simpler. They actually created VIA, which is literally a software that you install on your computer. And I think there's even a web page because it uses some special HID protocol on USB. So you connect your keyboard, the software automatically detects it, and then you can graphically say, oh, well, this key is an A, or this key on the layer 2 is going to be apostrophe or some other thing. So you can visually change and make the changes very, very easy. So, but again, it's all within talking to QMK. Now, if you want to create your own keyboard, well, let's go a little bit crazy here. If I want to create my own, well, this one is black on black. Well, my own like special layout keyboard, then if it's not in QMK, what do? Either you have to kind of go and get a whole QMK tools chain and configure your own files, or you can go and say, okay, well, I'm going to go just simple in Arduino and program my own. Or you can go in CircuitPython, if the controller supports it, obviously, and build your own. And again, these 3 steps are always going to be the same. You figure out which key is being pressed, you figure out your mapping, what key to what to send, and then you send.
So you've been working with Arduino the last couple of years, and then last year you launched a new keyboard that actually uses Python. What led you to that?
Well, essentially last year, like it was the great chip shortage of, well, and we're still in it, so we can't just say 2020 or 2021. But last year, the RP2040 came about, and a lot of the other chips, including the NRF52s, were getting scarce. So I thought, okay, I gotta do something a little bit different. And then this RP2040, like Raspberry Pi, they've made it really, really simple to build your own PCBs and chips, because they've got a really great guide on here's how to design your own device with the RP2040. They've got a how do they call it, essentially a hardware building guide. So, and they even have a KiCad set of files that you can use as reference. So I said, okay, well, I know how to build keyboards. I know how to design keyboards. I've done quite a few. And I said, okay, well, let's just take the RP2040 and just like put it all in. And then like this, it all came about. And like, for example, like at work, this is like I use like my keyboard, and it just like it runs. It's got, okay, I don't use the RGB, but it's got RGB and hot swap sockets, all the nice and sexy things nowadays. But it's I built it and said, okay, well, let's make it like available, and it's actually open source, but I do have quite a few available if anybody wants some. And but it's and I actually created it, and it's like, okay, well, with CircuitPython, because just previously to that, I actually put my microcontroller on there, like the BlueMicro 840, and it was really simple. So it was like I really like can't can't attest how simple Scott and the Edifruit team has really made it simple to take your own controller, take an example that already exists, and then just say, okay, the only differences are these. I push it up, and then I think the most complicated thing was actually a getting all the documentation lined up to be able to get my own USB product ID for this, because there's some open source projects that can use those. So getting that was the hardest part, because getting the keyboard or the controller in the in CircuitPython was simple. So the next step with the keyboard is like, well, I just need to do the same thing. So and then that came along. I've got this keyboard running CircuitPython, and it was very simple to get it on there. The And then I've even had people, oh yeah, I want a bigger keyboard. And this is how this one came along. Was somebody came last December and says, well, would you kind of be, are you okay if I kind of like design it larger? And I said, yeah, sure. Like if you want to contribute it back, and I'd be like, I can just set up a small production run so you can have your own, and you can we can test it out, make sure it all works fine, and it works fine. So this is where the larger 87 came along, and they both run CircuitPython. They both like even setting it up on QMK or no KMK was very simple, because the examples are really simple. It's just a matter you set up again which pins are mapping to which rows and which columns, and then send disk key press whenever you detect that this key is detected. So it was very simple.
Well, that's great to hear. How has CircuitPython helped you with troubleshooting?
This is where, like, when I went going back to Arduino, and if I even go back to the days of QMK, when you look at QMK, let's go like the hardest difficult start first. If I want to create my own keyboard, or if I build my own keyboard, just even have it my own PCB, you're going to have a hardware problem. You could just say, oh, I have a short between these two pins, and then I've got like press a key, and then like there's like three that are showing up at the same time. So if you have QMK that's like all a prepackaged firmware with no troubleshooting tools of any kind, then it's very difficult to figure out what's wrong. Then you go to Arduino, where, okay, you've got to create a small program, compile it, and flash it. And then quite a few people are not comfortable programming, especially like I'd say in the mechanical keyboard community, there's like really two groups. There's those who like the keyboards, and that's really what they're in for, the keyboard feel. And then there's those leading programmers that, yeah, they're not scared of diving in and going programming. But by selling a number of keyboards and chips, like, and having that firmware, like having troubleshooting tools handy to be able to troubleshoot your own keyboard when something on the hardware does not work well is very useful. So I actually built a number of tools to be able to help people troubleshoot. Oh, well, is this thing working? Is it shorted? Is it like just like not connected? And then, so I've had a few tools there, but then I kind of like look at CircuitPython. It's like, oh my God, like you don't have to compile anything. You just copy the files, and it's like, is it working? No. Oh, just change a couple of things. Is it working? Oh, yeah. Okay. Found the problem, found the solution. It's so much faster to be able to iterate, because when you troubleshoot, it's always like your mind is working. Okay, do I need a multimeter? Do I need like try to see what's connected and not connected? Well, if you've got a microcontroller right there with all its spins already probing what you want to like see, oh, is this connected to this? Well, you can ask these two pins, are they connected? And then you'll be able to tell. So it's with CircuitPython, it's a whole lot easier to iterate so much faster on identifying the root cause of your problems and then moving on into, okay, I got to pick up the soldering iron and fix this little piece or that little piece.
Well, that's great to hear. We're almost out of time, but before we go, I'm a vinyl record collector and I have a segment called Turn the Tables. I enjoy the pun. I don't know if
Yeah.
everyone else does. But I've been asking all the questions. Now's an opportunity for you to ask me a question.
Yeah, I'm going to go a little bit different. Adafruit has been going retro lately with all the floppy disk stuff, but I'm going to go with a retro question here. If you go back maybe in your childhood or maybe the first computer you had, first computer game, and if you would pick, okay, here's the one game that kind of like, okay, I played it from end to end, or it was like the one thing that really kind of like hooked me, or kind of like, okay, I've got fond memories of. What would that be?
For me, it would be Broderbund's Load Runner on my Apple IIc. And it was a, kind of a platform scroller, and you could drill a hole and the bad guys would fall in the hole, or you had to drill more holes to go get the gold that was there. But what I loved about it is you could design your own levels. And that was the first
Oh, that's
game
neat.
I
Yeah.
ever played that I could design my own levels. And I remember just spending an entire summer just doing that over and over again and making it near impossible to play at times, but it was so much fun. If I had to go back, that would probably be the game that I would choose.
Yeah. For me, it would probably be Buck Rogers on the ColecoVision Adam. It was like in the early 80s, it was like the Adam was something that came and died very quickly. But the one game that came with it was Buck Rogers. And it didn't come on floppies. It actually came on cassettes. And unlike the C64, like the Commodore 64, those cassettes were like being read like floppies. So they were spinning like crazy to go back and forth. So you didn't have to wait to play till it loads everything. So and it was a game that was more like a space game that you were flying through some kind of 3D planet and you were shooting things. And I remember going from end to end of that game, but it was it's kind of like mind-boggling nowadays that if you look at the Adam, it was not even running at 4 megahertz. It had like 64K of RAM. Even that cassette had 256K of storage. Nowadays, even our little microcontrollers like the RP2040,
I know, it's amazing what you can do.
it runs like circles, or like it runs like tornadoes around what these things would be able to do back then.
Last question. If you're going to start a new project, which microcontroller do you think you'll reach for?
It's going to be one of two, and I'm going to kind of like divide it maybe even 4 ways. So if I just want to prototype something very quickly that I don't want to design like my own PCB, I would either pick the KB2040 because I've got a handful of them, or if I need more pins, I would probably pick a Pico. But if I need Bluetooth, I gotta go back to the NRF 52840. It's got USB as well, but it's got Bluetooth, and I've got quite a few of those of my BlueMicros. But I could like go for a Feather, or could even go like the bare bone module, which I'm just gonna pull out this one because if I build my own PCB, I could actually go and say, let's put the modules right on to build my own next keyboard. So, and this is probably an adventure I've kind of like started last November, probably. for like a super thin keyboard, like very, very thin. It was more of an experiment and just say, oh, let's see how low can I get it. And it runs again because it's based on on that same chip. I was able to load CircuitPython and get KMK running on it relatively quickly. So
That's so cool. Well, we're out of time. Pierre, thanks so much for being on the show.
thanks again for having me.
Thank you for listening to the CircuitPython Show, an independent podcast with the people in and around CircuitPython. For show notes, transcripts, and to support the show, visit CircuitPythonShow.com or follow the show on Twitter at CircuitPyShow. That's CircuitPy Show. I'm your host, Paul Cutler, and I'll be back next episode. Don't forget to hit subscribe and stay safe.